Yeah, thank you. So, as usual, what I'm going to do is I'm going to start by launching Jupyter. So, let me see how I can do that easily. I need to. So I go here and I can launch Jupyter. So I go to Anaconda, under it for me. In Windows, I have Jupyter Notebook, and I click on it to launch Jupyter Notebook. So it will take some time to come up. So today I'm going to go to a particular directory. So I'll show you how I can go to the directory. It's quite simple, actually. Okay, so it has taken me to this directory, but this is not where I want to work. I want to work in documents, and in documents, I have a file there, a folder there called Python Intro 2. So I'm going to navigate to the place. Okay, so this is my C drive, and then I navigate. I see documents, I can click on it. I think I double click on it. So it goes to documents, and then in documents, I look for Python.
Sorry, we can't see your screen. I don't know whether it's particular to me.
Okay, let me stop share. Let me share again. Can you see my screen now?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
So when I launched it, I was on this place. Okay. Then I actually want to go to a particular folder. So I look, which is in documents. So I look for documents. I think I passed it. Yeah, document. I double click it, and it takes me to this place, and I look for Python Intro 2. This is where. So I double click it. I think I don't have to go to data sets. So I'm going to open a new file now. A new Python Jupyter Notebook. So I do this. So it's going to open for me. Okay. Today is April 30, so I'm going to rename it as April 30. So I go to file and rename. It's on title, so I call it April 30. 2025. Okay. I rename it. Okay, so I have the file now. Okay. So I think the first thing is I want to open the CSV file. So if you go in this, so the data sets I need, I already put them in this folder and in this, don't worry, okay, and in this data set. So the one I want to work with, and we were working on before, is this pandas demo.csv. Okay. So in this place, I'm going to first import pandas as PD. And I also import numpy and then P. I think those are two that I will need. So I do Shift Enter, and I have it already here. So I wait for this start to go away. Okay, so I have it. So now I'm going to open the data file. So I said data file equals PD dot. What should I do next? I want to open the CSV file.
I need to read underscore CSV. Then
so now if I just do this, if I just do the name of the file, which is pandas
Demo.
dem CSV. It won't get it, so I have to tell it where it is. So
Okay.
because it's not just in Python Intro 2, which is where I am. This is where the Jupyter notebook is, but inside the data set, so if I click data set, that's where the CSV file is, the pandas demo CSV. So I'm going to put that there, data set. Actually, I think if you do this, it works. So whether you do this or you do the other slash. Sorry, I didn't close it. Okay. So we read it, and I can print the head. You see that you read the data. It's the same data that we had before. So read the data. So I say, what if I use, because this is Windows. Okay, so in Linux, you usually use a /. In Windows, you use a /. I don't know if this will work. Let's try. It doesn't. Let's see if I do // if it works. Yeah, so if you do // I think it works in Windows. Okay, and it gives you the same thing. Let's pretend as if we are all Linux fans, and we just use this /, and I can take it and I can take everything. Okay, and then if you want, you can print the statistics, and it will just help you to know for the numerical data, like that is this column and this column. It will help you to see if there are any in there or not. Okay. So for instance, in the other case, we saw that if you print the length of df, okay, it will tell you the number of rows that there, 11. And then if you do the describe, I think if I do this, yeah. So if you look here, the numeric columns are enrollment and rating. So instead of having 11 enrollment, there are 9. So 2 are missing. Instead of having 11 ratings, there are 8. So 3 are missing. So this helps you to know some things like that. Okay. And then we saw how to use iLock to find a particular element. So for instance, this is row 0, and this is element. So this is 0, column 0, column 1, column 2, column 3, column 4. Okay, so Aaron is row 0, column 1, because it starts from 0, 1. This one on this edge, 0, 1, 2, 3, 4, is Jupyter that helps you to write it. It's not in the file, it's not in the original file. So if I open the file and we look at pandas, let me try to do this CSV file. Does it open? Or do I have to open it special? Okay. Okay. So this numbers 1, 2, 3, 4. I'm not the one that gave it to it. Okay. Is the okay. What I want to do is I want to open the file itself so that you see that the index, I didn't give the index to it. There I can open it. No, I don't want to delete it. I just want the way to open it so that you see that okay. Maybe I can do that later so that I just want you to see that I didn't give the index to it. Okay, the index is not in the file. Okay, maybe I should just go here. I think it's this path 122. Yeah. So if I look at the file here, where is it? Pandas demo. Open it with Notepad. And I can make it as big as I want. Okay, you see there's a column with index 0, 1, 2, blah, blah, is not here. Okay, so it's Jupyter that's kind enough to give us this index. So you should remember it's not there. It's not there, yeah. Okay, so I have this file. So this column, module ID is there, instructor is there, TA is there, enrollment is there, rating is there. Describe will only give you data information about the columns that numeric data. So for TA is non-numeric data, it doesn't give you any information. Instructor is non-numeric, so it doesn't give you information. Module ID is non-numeric. So in describe doesn't give you information about all those ones, but it gives you about enrollment and rating. So if I want to get Beth, for instance, this is row 0. Okay, this is row 1, and this module ID is column 0. This is column 1. So Beth will be row 1 and column 1. Okay. So if I do ilock, so I can tell it to print f.ilock, and I can do 1. So it prints exactly Beth. Okay. Then you can also use lock. Okay. Lock, you use it just like you use ilock, except that you don't put numbers, you put the heading, the column heading. Okay. If there are row headings also, a heading for each row, you have to put it. Okay. So for instance, if I want Beth, okay, the column is instructor, and then the row, okay, in this case, there's no row. Okay. There's no row. The row is not labeled according to it's not labeled with a string. Okay. So if I try to do that, it won't do what I want it to do. So I should, in principle, do I lock, okay, and then I'll give it a row index, row name, okay, and then the column name. Okay. So this is how you should do lock. Okay. In this case, I'm going to just grab all the a particular column, okay, and irrespective of what row it is. So in that case, I'm going to do df.lock. Okay. I'm going to get this column means I want to get all the rows. Okay. And then I need to put a column name there. Okay. So with ilock, you put numbers, okay, but I stands for integer, so integer location, ilock. But with lock, you put a proper name. So in this case, I want to get all this row. Sorry, for instructor. Okay. So first, you need to know exactly what this instructor, what the column names are. Okay. Because there's a space here. So I don't know whether it's instructor with a space or what. So the best way to do it. So if you just think, oh, maybe I should just grab this instructor, you may be wrong. So the best way to do it is first to grab the column names. So I'm going to print df.columns. So it grabs the column names from me. So all of them, none of them have space. Okay. There's some other times that you do it and you will not know that there's a space there. So I can just grab instructor like this and just copy it and paste it into what I need. Okay. Sometimes it will have a space and you don't know that it has a space. Okay. So here I'm going to grab this. I'm going to grab this. I'm going to do this. So this will just give you the column that belongs to instructor. Okay. So this is the instructor column. So of course, let's do print. Okay. If you don't print it, Jupyter is nice enough to write it for you, but it's good to print it. So I printed it. So it printed the column I want. Okay. But every row. So because the rows are not don't have a name, so I can't pick a particular row with lock. Okay. Then I printed the instructor. What if I want to print the instructor column and I want to print the rating column also? So I do the same thing, a similar thing. I do this. Okay. Well, you have to put this in a box, in braces. So I do this and I do the next one also. I do this. Then it's going to print for me the instructor column and then rating. Okay. Yeah. There are other things that you can do. For instance, I can create a series that okay, let's do this. So what I'm going to do next, I'm going to create an array. And the name of the array, okay, so I'm going to create an array. And what this array will contain, it will be a series. And whenever the module ID is CS10, okay. In this thing, is going to put a yes, sorry, for is true there. And when it's not, it's going to put a false. So if I do this and I hit Shift Enter, let's print. So this, I put DF module ID. DF module ID refers to that particular column that has module ID. Okay. So first, I can just do print on DF module ID. It's best to just copy and paste. Okay. So it printed just the column I wanted. Okay, this column that has module ID. What if I want another column? So you can think that maybe it's similar to the lock that I'm doing. If I want a column that has the rating also, I can put rating. Now I'm not sure whether I have to put double brackets or not. Let's do it. So yeah, I think I need to put the double brackets. Yes, because there are two. Okay, so it prints both of them. So just like in this case, that if I'm printing two of them, I have to put them in a list like this. So it prints this. For this one also, you put it in a list and it prints both of them. Okay. So I access them this way. Actually, another thing I can do is if I want to access this particular value, okay, it turns out that, can I do it? Okay. I'm not sure I can do that directly. Okay. So I have this. So let's go back to this. So I created this array one equals df module ID equals CS. What this does is that it takes a look at the data frame, okay? And then it takes a look at this column that has module ID. And everywhere that CSC 101 is true, sorry, everywhere that this module ID is CS 101 is going to put true there. Everywhere that is not one of CSC 101 is going to put false there. Okay. So if you look at this, it's going to put true here, true here, true here, then false everywhere else. Okay. So that's the array I'm going to get. So if I print array one, so I'm going to get true, 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 because those are CS101, and then the rest is going to give me a false. Okay. So how can I use this array? Okay. Sorry. Okay. So how can I use this array? I can just print the array that has where df is true. So to do that, if you do df, so if I do df and array one, okay. Remember, array one is true for the top three lines. Okay. So if I do this array one, it prints only the top three lines because those are the ones that has true for array that have CSC 101. Okay. So let me go over it again. So what I'm doing here is I create an array. And what this array contains is it contains true whenever module ID is CSC 101. So this is what it's doing here. Whenever module ID is CSC 101, it contains true. Okay. Whenever module ID is not CSC 101, it contains false. So this is what this array one contains. So I can print the array one. So here I printed array one. the first three lines are true because if you look at the original data, only the first three lines have CS101, CS101, CS102. Okay. So now the next thing I did was to say, I want to print the data frame, but only when array 1 is true. Okay, so that will be only when module ID has CSC101. So it has printed it for me. This is what it has printed. If you want it so that it gives you only the one that has CSC 103. That's this one, this one, this one. You can do it also. So you can define array. So let's try with another one. Let's say I want another one where I want the CSC ID to be 101 and I want the instructor to be Aaron. Okay. So that means I just want this one. Or I want the, yeah, that would mean I just want this row. Okay, then you can do it also. Or let's say I want all the ones that is CSC 101, but the rating is 9 and above. Okay, so I can do that also. So I can create another array because so it's data frame and the rating is greater than or equal to 9.0. So I do this. If I print array 2 now, okay. So the first two are true because the rating is greater than 9.0. And then there's another one that the rating is greater than 9.0. Okay. Oops, sorry. So there are three of them that the rating are greater than 9.0. Okay. So let's print all the ones that have CSC 101 and the rating is greater than 9.0. Okay. So it has CSC 101 and the rating is greater than or equal to 9.0. So it's going to print just this and this. Okay. There's another one down there that the rating is, so this CSC 103, the rating is 9.0, but I don't want it to print it. The reason is I only want those that are CSC 101 and the rating is 9 or greater than or equal to 9.0. So it won't print this one. So what you can do is you can tell it to, you can do DF and you can do array1 and array2. So there'll be, it will print the data frame for which array, this, you have array1, where array1 is true, and also array2 is true. Okay. So array1 means that it's CSC 101, array2 means that the rating is greater than or equal to 9.0. Okay. So if you tell it to print this, it's just going to print only those ones, the first two, because it's only the first two that has, the first three are CSC 101 and only those ones. And of those ones, only two of them have rating 9.0. Okay. This is very, this kind of, they call this masking. And this is very useful because sometimes you don't want all the data, you only want to select from the data. So it's good to know how to do this. Yeah. Does anybody have a question so far? Okay. What if I want to create another column? Oh, by the way, when I do all of this, the DF is still there. It has not changed. So if you print DF, okay, it's still the same data that you have. It has not changed because I didn't change it. Okay. All this that you are doing is just select a particular one. I can create another data frame that contains only this that I've selected. So to do that, I'll just say df2 equals this. But df, the original one, will still be there. So I will just say df2 equals this. Okay. Okay. And then if you print df2, there's a data frame that contains only just these two rows. Okay. The header is still there and everything is still there. And if you like, you can do a describe for data frame 2 also. Okay. And it describes the data. and only one of them has enrollment, two of them have rating. You can find the length, you can do different things that you want to do with it also. Okay. So this is what you have. What if I want to add another column to this? Okay. So you can add a column using different things. So I can for instance, I'm trying to see I'm not sure this will work, but let's try one thing. So I can create I want to introduce another column. The column is, I want it to be product of rating and enrollment. So I want it to be a product of the rating and enrollment. So let me try this. I don't know if it will work. If I do this, sorry, df. Okay, let's do a simple one. I want it to be twice the enrollment. Let's just say twice enrollment. Enrollment. This one I know will work. Okay. So I introduce a new column, twice enrollment, and it's just df, and it's the enrollment column. And then I multiply it by 2. Okay. So I do this. Okay. It seems as if nothing happened. But if you now do a head of the file, you will see that there's a new column introduced, which is called twice enrollment. It's twice this column, 38 by 2 is 76, 28 by 2 is 56, because of what I did. 39 by 2 is 78. NAN by 2 is still NAN, because there was nothing there, so I can do this. Okay. The one I was trying to do, I don't know if it will work. So, well, let's give it a try. This is one of the things with computers, shouldn't be afraid to try something. At worst, you have to restart your computer if it freezes. So let's call it rating x. That's times enrollment. So I don't know if this will work. Well, let's try it. Did not give an error, so it doesn't mean it worked. But so let's print df. Okay, so yes, so there's a module ID, instructor, TA, enrollment, there's rating, there's twice enrollment, which I already did before. And then there's rating times enrollment, okay, which is just this times this, or this times this. So 38 times 9, you can check, it will be exactly 342. And 28 times 7 will be exactly 196. So it gives you this. So you can introduce columns like that from the other ones, or you can multiply them by different things. Okay. So these are some of the things that you can do. I think you can drop a column. I don't remember how to do that. Well, you read it up on how to drop a column. You should be able to just drop a column that you don't want. Of course, you can list all the columns that you want and just create a new data frame that has all the columns that you want. But I think there should be a way to drop a particular column that you don't want. Because suppose you have like say 100 columns and you want to drop one, it doesn't make sense to list all the ones that you want. Okay, it's better to just find the one you don't want and just drop it. Okay. So there should be a way to do that. I'm sure I've done it before, but you can look it up online and you'll see how to drop a particular column. Okay. You can find the correlation for um, matrix. That one I think we can discuss about it later on. Okay. So I think this is about what is reasonable to cover on pandas. There are many other things that you can do with pandas. So for instance, let's drop all the rows that have not a number. Okay. So if I do df, they'll drop an A. If I do this, okay, it drops all the rows that have not a number. Okay. So twice enrollment is still there. Rating times enrollment is still there. All the columns are still there. But you see, row 1 has been dropped because it has not a number. Row 4 and 5 have been dropped because they have not a number. So you can do that. You can drop the ones that have not a number. And if you want to drop a column that has not a number, you put axis equals 1 like we discussed the other time. Okay. Let's get just the columns. Let's get just the enrollment and rating column. Okay. So I'll call it DF3. So it's DF, okay. But I want just the enrollment. Ouch. I want just the enrollment. Okay. And the rating column. So if I print DF3, it gives me the enrollment and the rating column. Yeah, okay. Then I can drop the ones that have NaN. So I can do, if you just do df3.drop NaN, drop Na, sorry. Okay. Okay, it does this, but it has just printed it to you because this df3.drop Na, it returns a data frame where the not a number have been dropped. But I'm not storing that data frame into anything. Okay, so df3 will still be the same thing as it was before. It's not changed. Okay, so if you do df3, okay, it's still the same. It has still NaN. Okay, so what you can do is you can put this df3.drop Na into another df data frame. So you can do, if you like, you can put it in the same data frame. Okay, so I do df4 is this. Okay, so if you print df4 now, it's this data frame, but the NaN have been removed and df3 is still there. What if I want to use a new data frame? I don't want data frame 4. I still want data frame 3. So in that case, you can just do df3 equals df3.drop Na. If you do this, it's going to override df3 with the one that does not have not a number, and you lose df3 that you had before. So if I do this now, okay, and try to print df3, it has this, okay, and the original df3 has been overwritten because I put df3 is df3 dot drop any. Okay, so so now I can do the correlation for df3. Okay. Okay, so enrollment is perfectly correlated with enrollment. Rating is perfectly correlated with rating. Okay, but the correlation between enrollment and rating is 0.2. Okay. I think this one gives you the Pearson correlation. I'm not sure, but you should be able to also get the what do you call this? Spearman correlation. Let me check if if this will give me any information um, about what you can get. I want to see if you can get both Spearman and so I don't know if I did the right thing. Yeah, I don't know if I did the right thing. But if you read on it, it should be able to tell you whether how you can get Spearman correlation coefficient or Pearson correlation coefficient from this. Okay, from this correlation matrix. Okay. So this is useful because if you have okay, for instance, okay, let's do this. Let's take let's make DF3, this one, and the one that is that are added, which is rating times enrollment. Okay, let's try to do that. Let's make DF3 this, then rating. I do DF3 is this. I print DF3, it has this column. I drop NA, that has this. And then I can print it. There'll be 3 columns. Okay. Now I can do the correlation. Okay, so I print the sorry, not this, not the correlation. So I print the correlation. Okay. So you see, rating times enrollment and enrollment has a very high correlation. Okay. After all, rating times enrollment is rating times is this rating X enrollment is actually enrollment times the rating. So there's a correlation with enrollment, and there's a correlation also with rating. A high correlation, sorry, with rating. Okay. So enrollment has a perfect correlation with enrollment. Rating has a perfect correlation with rating. And rating X enrollment has a perfect correlation. Okay. But you see now that rating X enrollment has a high correlation with enrollment. It also has a high correlation with rating. Okay. The reason is obvious because I just multiplied those 2 columns and I have it here. So let's say you are doing machine learning and you didn't know that 2 columns were correlated. Okay, you can do this and it can show you which ones are correlated. And then you can decide that, oh, the features that are very correlated, maybe the correlation is greater than 0.5, then you don't have to use both features. You can drop one of them. So in this case, if I see that rating that this column, rating cross enrollment, has this high correlation with rating, then I could either drop rating or drop rating cross enrollment. Okay, so that will reduce the number of features that I have. Okay, because these other features are correlated anyway. It's like when you do the fit, for instance, later on, if you do that project, you will see that the mass of the elements is perfectly correlated with the atomic number of the elements. So if you have a particular structure and you calculate the mass of the structure, it will be perfectly correlated with the atomic, well, almost perfectly correlated with the atomic number of the structure. Because for many elements, the atomic mass is about twice the atomic number, okay, because you add the number of neutrons and protons. So in that case, then if you say, for instance, like superconductivity is inversely proportional to the mass to the square root of the mass of the atoms in the system, okay? Someone else could say, it's proportional to inversely proportional to the square root of the atomic numbers. Both of them will work in machine learning, okay, because they are correlated, the mass and atomic number. So you probably want to drop one of them, okay, when you do the machine, develop your models. Yeah. Okay. So I think we should go on ahead now to. Does anybody have a question with that? Oh, so there are different ways So in this case, I dropped the missing data. Someone says, what if you don't want to drop the missing data? What can you do? You can fill the data with a mean. So this is one way. And then there are, or you can say, okay, if it's not there, I can fill it with 0. Okay. Or you can fill it, say, with a mean. Okay. So let's try to do this. So I think I have df. Okay. So if you do df dot fill na, and so what I want to do is I want to I just want to take the column that has numeric data, and I want to fill it with the mean. Okay, so I'm going to do this. So df. So let's say rating. Okay. So I'm going to fill it with the mean. Let me see if this works first. Okay. And then I'll print df2. Oh. Okay, so you see the rating column has been filled. Okay, before when I started with df, the rating column, some were missing. So if I look at df, you'll see that some are missing. Okay. Particularly, you will see that this fourth one, the rating was missing here. It was NAN. Okay. This one also, the rating was missing. It was NAN. This one, the rating was missing. Okay. The reason I know, okay, so you can check. So you can, let's print df2 or df. Okay. So if you look at the rating here, for this line that's labeled 4 is NAN, 8 is NAN, 10 is NAN. Sorry. So 4, 8, and 10, they are all NAN. Okay. So now when I did what I did, so you see that 4 now has 7.875. Okay. 8 also have 7.875, and 10 also has 7.875. Okay. Because what I did was I said it should fill not a number. And you should look for this one that has DF rating. You should fill it with the mean. Okay. So it fills DF with the mean, and it puts it in DF2. Okay. If I do DF, it should still give the original thing, but I put it in DF2. So DF2 now, everywhere that there was a rating, and the rating said not a number, it will fill it with the mean of that column. Okay. So if you find the mean of the column before I did the rating, okay. I mean, before I did the fill, you'll find that the mean was 7.875. So I filled the not a number with 7.875 because so you can do that also. You can fill with the mean. Yeah. Okay. Okay. So I think the next I want to go on to is matplotlib. It's just a very good way of plotting things, and it helps you to plot things very easily. You need to import it. Okay. So I've already imported NumPy and Pandas, so I can import matplotlib. Ouch. Ouch. So I just import matplotlib.pyplot. as PLT. Okay. So this simple thing allows you to do quite a lot of things, visualization and everything like that. Okay. So we can start by using it to plot sin x. So what I'm showing you now is exactly sorry, what I want to show you. What I want to show you is exactly yeah, let's go ahead. This is pandas, and then yeah. Okay, so I'm going to try to do this. Okay, this x equals np numpy dot linspace 0, 10, 100 means it's going to create 100 points, okay. Including 0 and 10, and the points will be evenly spaced. So this is what this will do. Okay. Then this y equals np dot sin x will create for every, okay, let's do it one by one. We'll print x after we do this, and then for every element of x we are going to take the sign. Okay, np can do things in parallel, so it's going to take this sign of everything for us at once. Okay. I'm not very good at this figure thing, so I don't know if I'll do it. I can do it because it's there, but if you just do plot xy, it's going to plot for you. You can put the title, you can put the label, and you can print a grid, you can tell it to show it, and there's a way to print it also to file. Okay, I think we can find that out later. So I'm just going to do this, and then we'll print this. Okay, so let's print x. Okay, so it gives you all the numbers from 0 to 10. Sorry, yeah, from 0 to 10, and there are 100 of them, and they're evenly spaced. Okay. So because 10 is included, so all the numbers from 0 to 10, 10 is included. They're actually, yeah, 10 is included. So this is why it's 0 0.10110, like this. Okay. If you wanted to give you something that is exact and does not have something like this, you can do it also, but then you have to think a little bit to know instead of 10, I should do, oh yeah. So if you do this, if you do it up to 101, okay, and then I print it, okay. So it gives you in steps of 0.1, okay. So because 10 is included, okay. So now it prints for you in steps of 0.1, okay. So I have 101 points, okay, from 0 to 10. 0 is included, 10 is included, and then 101 points like this. So it prints this, okay. So it's exactly a list like this. You can find out what the type is. It's a numpy array, okay. So because it's a numpy array, you can act in parallel on this. So if I do y equals np dot sign x, okay, what this will do, it will take the sign of each of the numbers that are in this array. So to find sign of 0, sign of 0.1, sign of 0.2, up to sign of 10. Okay. So it's going to print it for me. So it's going to calculate it. Okay. And then I can tell it to print it if you want, but we don't have to. But let's print it. Okay. Then I can plot x against y. Sorry, y against x. So x first and then y. And then I plot this. Sorry, plt.plot, because I imported numpy matplotlib as plt. Okay, so here is as plt. So if I do plt.plot, then it's going to plot for me. Okay. Okay, so it plotted exactly sine for me from sine 0, from 0 up to 10. Okay. Actually, it's plotting this as points. Okay. How do I know it's plotting it as points? Okay, so let's do this. Let's reduce it instead of 101. Let's then reduce it to 11. Okay. Then I don't have to print X and everything. So I reduce it to 11, and then if you do Y is MP sign, if you print it, it does. But if you plot it now, uh, actually there's a point here, then there's a point here, there's a point here, and I'm not entirely sure why it's plotting it with. Oh yeah, I think it's just joining the lines. Okay. If you want it just to be points, you can use PLT to scatter and X and Y. Okay. We're just going to plot the points. Okay. So these are just points. And if you want both of them together, you can do this together. But you do one after the other, and everything we show together. Okay. So the points are showing with the scatter, and then the line is showing with the plot. Okay. The plot is the one joining the line. Okay. So we can go back and do something that is more refined and use 101 points. Okay. So the tutorial manual tells us more about this. That you can, yeah, you can show the grid. Okay. So you can say, you can label the axis. You can put the title. You can label axis, while you can label the y-axis like this. You can put a grid and you can display everything. So let me do a few of them, or let's do a few of them. So let's put a grid. So you're going to put a grid, and then let's also put a title. Rough sign, and then plots X label. I just put X, and then PLT dot Y label. Let's put sin X. Let's put Y equals sin X. So we plot and we get the title is rough sign plot. And we have the plot and have this. Okay. There's a way to print it to a file. I think you have to do plt dot. I've forgotten about this. Okay, but one of the things you can do when you imported matplotlib, you can. When you imported matplotlib, you can. What did I do? You can force it to pop out something. Yeah. Okay, I can tell you more about it later. You can force it to pop something out. And then once you pop something out, then you can do the plot to, you can click and tell it to plot to save the plot as something or as something else. Okay. But there's a way also you can do it on the command line, where you tell it exactly how you want it to, that you want it to print it to a PDF. So there's a way to do that. Unfortunately, I don't have it. But I'll be able to refer you to it. Okay. Then this thing also has things about how to work with subplot and how to show the subplot. And yeah, so you can do save fig. Yeah. So I can save the figure and then it's going to save. Okay. Ideally, you should do plt.show. Okay. But Jupyter shows it for you anyway, whether you show it or not. Okay. But if you do plt.savefig, and I can just say let's call it my plot.pdf. Okay. So I think this will automatically save it as a PDF. Okay. So when I do that, what's the name? Jupyter plots it, okay. But if you look here, I should have a file. Where do I have it? Phone. Yeah. Yeah, you see, I have this my plot, which is a PDF file. I don't know if I can open it with, okay, open with PDF. So open the PDF editor that shows me my plot. Yeah, so this is a PDF plot. So there's a PDF file there that I can use. If you had saved it as my plot.png, it will create a PNG file also that you can include in your LaTeX and take a look and use. So I can put plt.save. Okay, and then there's my plot.png. If I do that, then I can check here. There's a plot PDF and there's a plot PNG also. Okay, this PNG then you can insert it in your. Okay, I can open it with image. You can insert it in your LaTeX file and when you're doing your writing your paper. Okay, so this one is a PNG file. Okay, the other one is a PDF file, so you can send it to a friend and do different things that you want. You can also plot a histogram. We have to have the data in the right way, and then you plot a histogram. This is good. Okay. Any questions so far? Because I think the next thing we'll do now is we go on to scikit-learn and try to do.
Sorry, Prof.
Yes. Yes.
Is it possible to put a key?
Oh, to put a key. I think it should be possible, but I don't know. So someone can help us to find it. I should be a place to. I know you can set the label. And then if you want to set the key, I think it should be possible, but I don't know exactly how to do it. You're right, because you may want to have, let's say you have two plots in the same place. You want to say that the red one is this and the green one is something else. Yeah. Okay, I'll find out and try to show you the next time. Yeah.
Okay, sir.
Okay. So, okay. So now this is how to deal with data. And the truth is, this is an important part of machine learning, although it's not the glamorous part. Okay, like when they say there's DeepSeek or there's ChatGPT, they trained it. They don't talk about how they got it, data, how they spent a lot of time cleaning the data and doing different things before they were able to do the training of the model. Okay, but this is an important aspect of everything that you have to do. Okay. Okay. So now we can go on to machine learning proper. Scikit-learn actually. So scikit-learn is actually a set of libraries that do different things. And I won't tell you that I know everything offhand. Okay. But what I typically do will be to go online and um, see how to use whatever module or library that I need to use. So now you know what a library is, you know what a module is. Okay. Um, Scikit-learn is kind enough to give us a lot of things that even many of us don't use. Okay. It can give you an estimator. This is the thing that creates the model. So you can do linear regression. Okay. You can do support vector. Actually, I would have said SVM, support vector machine. Well, this one I think is support vector classification. Okay, you can use it for classification. You can do unsupervised estimator, K-means. K-means is for clustering. Okay. And like K nearest neighbor. Okay. And then you can do PCA, principal component analysis. So we are going to do at least some of them. And then uh, there are different transformers. I'll talk about one of them. Okay. So if you have your input data, for instance, your input data, you have the age of the person. No, age is not a good thing. So let's say you think the weight of the person correlates. Okay. So let me see. What am I sharing now? Okay. Let's share something else. This is what I want to share, but I don't see it. I want to share something, but I don't see it. Not this, not this, not this. Share everything controls on this, not this. Not this, not this. It should be this. Sorry, I'm looking for there's something I want to share. Let's go for instance. You're supposed to have something that says, sorry, still looking for it. Okay, not this. Not this, not this. Okay, so I think it's there, so I have to look for it. Sorry, give me a minute to look for what I want to share because then it helps me to be able to. Is it this one? No. So this one I can kill it. It helps me to be able to write so that I can write on the screen. So it I want to do. Not this and not this. It's a sticky note. Interesting. Oh, I think maybe it went off. Well, let me try to do it again. Okay, perfect. Okay. Okay, can you see my screen now?
Yes, we can see your screen, sir.
Okay. So we have estimators. So yeah, so we looked at, we will almost definitely look at linear regression. And support vector classification, we look at it also. Unsupervised estimator, when we do research, we can do it, but for this class, we won't do it. Okay? Transformers, we will look at some transformation. Okay? And then pipeline also, we look at it. I'll explain both of them just now. Okay, so let's say you have set of data, and the set of data consists of the person's weight, okay, and then the length of the thumb, okay, and then what else? The waist, okay. And the claim is that the person's that if I measure the length of the thumb and the waist, I can tell the weight of the person. Okay, so I can have data like this. So the weight is your target, okay, is Y. Okay, the thumb length is X1. Thumb length is X1 and waist is X2. Okay. Actually, please, could we pause for a while? Someone is, I need to. Okay, sorry. Thank you. Yeah. So let's say the weight of the person. I'm saying that I can predict the weight from the thumb length and the waist length. Okay. So let's say the person is 80 kg. Okay, and another person is 50. One is 95 kg. Okay. Let's put another person that is 40 kg. Okay. The thumb length for this one, let's say is thumb length is 2 cm. This one is 1.5 cm. This is 2.5 cm. This is 1 cm. The waist is really very large. So let's write the weight in millimeters. Okay. Well, we could write it in cm, but let's say this one is 50 cm, the circumference of the waist. Okay. But let's put it in millimeters. Okay. So this one, this is maybe for 20 millimeters, which is 42 cm. 50 kg, this is, this guy is lighter, so maybe it's millimeters, and this 40 kg is 400 millimeters. Okay, let's do something like this. Okay, so my first guess is that I can do a linear regression. I say that that y is a constant times x1 or the constant times x2. Okay, so I'm going to use it. I'm going to put all this data in it, and I'm going to try to make a prediction. Okay, so at the end, what you're going to do is you're going to put the original y here. Okay, and then the prediction from this model, we're going to put it on this axis. Okay. So usually we draw a line. Okay, if the prediction and the original y are the same, all your points will lie on the line. Okay, so this one shows that the prediction and the model, sorry, the prediction, that's the model, and the original data. If they lie on, if the prediction lie on the same straight line, on this y equals x line, on this line, okay, then it means that the prediction is perfect, okay, or the model is perfect. But what often happens is it won't lie exactly on the line. We have something like this circles. Sorry. You have the circle. So this one, the model over predicted. Yeah, the model also over predicted, and then the model can under predict. Some cases is almost close to it. Okay. So in this case, you have something like this. Okay. So this that I've shown you is exactly linear regression. Actually, usually there'll be another constant here because it may not be exactly like this. So there'll be a constant here. Okay. A naught, which we'll try to determine also. Then there's A1 and A2, which you try to determine. So if you look at the equation, like these things, okay, x2, the magnitude is much greater than, I mean, this number is much greater than this number. So this number is much greater than this number. So if you just do a fit like this and try to reproduce this, you will get that ultimately this number will be very small because x2 is large. Okay? And then this number, okay, A1, okay, maybe average. Okay. The reason is because x1 is 2, 1.5, 2, 1.5, or maybe large. Okay. So A1 will tend to be large, A2 will tend to be very small. Okay. So when you do a fit like this, numerical noises can happen. So A1 can have values of like 10 to the 6, and then A2 can have value of like 10 to the minus 6. Okay. So no, okay, this will not happen. So let's say 10 to the 3. And this one will have values of like 10 to the minus 3. Okay. So this will be of the order of A1, and this of the order of A2. Okay, will be 10 to the minus 3. The problem is that you have a number like 1,000, and you have a number like 0.001. Okay. And because of the difference, large difference in scale, this is not very good numerically. So what we try to do is, instead of using x1 as it is, we scale it, and instead of using x2, we scale it. Okay? So we scale x1, okay, to x1 tilde, okay, and we can let it lie between -1 and 1, okay? And then x2 also, we scale it to x2 tilde, and we let it lie between -1 and 1 also. Okay? So x1 tilde, if you scale it, we can scale it by the largest here. Oh, sorry, by the largest, which is 2.5 cm. So in that case, you can just say that x1 is x1 tilde is x1 over 2.5. Okay. And then x2 tilde, which is scaled, is just x2 over the largest, which one do you have? 500. Okay. So if you scale it this way, you see that x1 tilde can never exceed 1. X2 tilde also can never exceed 1. Then your A1 and A2 will be comparable. Okay. So if A1 is like 10 squared, A2 will also be about like 10 squared. So you don't have this like difference anymore that you would have had. And this is because you scaled it. So x1 tilde, the maximum value will be 1. X2 tilde, the maximum value will also be 1 because you did a scaling. Okay. It turns out that scikit-learn has libraries that can do the scaling for you. So you don't have to do the scaling yourself. You call a library. If you look through the data, it will know what the maximum is, what the minimum is, and then to do a scaling for you. Okay. So you can do that. So one of the things that you may find useful is that before you do anything, you can transform your data. So from X to X tilde. Okay. And there are functions or libraries in scikit-learn that can help you to do the transformation. Okay. So when you want to make a prediction also, okay, your prediction, if I now give you a value, say somebody has a thumb length of 1.8 cm, okay, and a waist of 380 millimeters, okay. How do you find the prediction? First, you have to divide the 1.8. You have to divide it by 2.5. the 380 in this example, so you have to divide it by 500. Okay. And then you use these values in your model. So your model will now be y is a naught tilde plus a1 tilde x1 plus a2 tilde x2 tilde. Okay, so you now use these values here and these values here. A1 and A2 and A naught you already got, and this will give you Y. Okay, so again, you don't have to do the division yourself. There are modules in scikit-learn that once you give it the model, it will design the model in such a way that it will do the scaling for you. Okay, and so you will just give the 1.8 cm 380 millimeters, and then the library will, the model together with the library will do the scaling and will predict Y for you. Okay, that process of taking the data, doing the scaling and everything, you can put it in a pipeline, okay, so that you don't have to call a function to transform and then another function to predict. You can put everything in the pipeline, and then the pipeline will do the transformation, the prediction for you at one go. Okay, so this is so there's a pipeline that you can use, okay, that can do the multiple steps for you. For instance, the multiple step of transforming, okay, finding the estimator, okay. It can do everything for you, so you learn how to use it, okay. The other good thing is that scikit-learn or sklearn, it has some data sets within it. So people usually, if you want to practice, you can just load the data set and use the data set. So the data set are in the program. When you install scikit-learn, the data set is there, and then you can use it. Okay. This one we'll probably talk about it later on. Yeah, the pre-processing is part of the transformation that I mentioned to you. Okay, and you can use the different scalars that you can use. And once you do a fit or once you train a model, how do you know how good the model is? One of the things is you can calculate some metrics. Okay, one of the metrics is you can calculate RMSE. Okay, so this is basically something like this: 1 over square root of n. Take the y, the prediction. You subtract the y, the original. Okay, you do it for several data points and then you square it. If you like, you can add a weight to it. Okay, and you take the square root, so you can do this. You can also find the mean absolute error. Okay, so there are different ones that you can use. Okay, so you need to define a metric. Okay, so you choose a metric and then you use the metric. So there is mean squared error, okay, which is the one I just did. There's a way to use the confusion matrix. This is basically when you're doing categorization, because with machine learning also, you can categorize. You can develop a model that just tells you whether this person is going to have cancer or is not going to have cancer. Okay. And so you can use machine learning for that. It's not only to predict like when this person will have cancer or how many years this person has to live. You can do categorization also, whether this person has cancer, will have cancer or will not have cancer. You can do all that. Okay. So when you do categorization, this is when accuracy score comes and the confusion matrix also comes. So we are going to use linear regression. Okay. You can also use logistic regression. There are all these other methods, ridge lasso. I don't really know much about ridge and lasso. Okay, so usually the one we use is linear regression. There's random forest also, which is an example on the sklearn tree. There's logistic regression, which is okay to use, but you probably can just use a classifier, okay, like a decision tree classifier or decision tree classifier. Okay. Yeah, you can use a single decision tree. Actually, nobody does that anymore. Okay, what we use is a collection of the decision trees, and then we take an average. So people usually use the random forest classifier. So random forest classifier is something that's taken from decision trees. Instead of having one tree, okay, you can use many trees, which make a forest, and use that to make a decision. Okay. There's support vector machine, okay, classifier or regression. Can I tell you how this works? There's neighbors. So if I, okay, so for instance, if I want to predict the weight of somebody from the thumb length and the waist, okay, one of the things is if somebody has a thumb length of like 1.6 cm and the weight and the waist is like 350 millimeters, okay. Without doing any calculation, I can go through this table and see which weight is closest to these values, okay. So there's 1.6 cm and 350 millimeters. So it's closest to this, okay. So I can approximate and say, okay, it's closest to this, okay, and then is next closest to this one, okay. So one thing you can do is you can take the average of this and use that as the weight of this new person. So in this case, you see, you take the nearest neighbors and use the average of the nearest neighbors to say what the weight of this one is, okay. So in this case, you can say, I didn't really do any calculation, but I did. I have to look for which x1 is closest to 1.6, which x2 is closest to 350. And so I found this one is the first closest one. This one is the second closest one. And I can use the average from this 50 kilogram and 40 kilogram to say that I think this person will be like 45 kilogram. Okay. So you can do something like that. But if you have many descriptors, x1, x2, x3, sorry, x3, x4, and on like that, you have to compare all of them, and you have to be able to say that when I compare all these factors, then I think it's closest to this particular line or this particular line or that particular line. Okay. This is where, yeah, this is why you need to do machine learning, because then machine learning will help you to know which factors, which descriptors are most important in making the decision about the weight. Okay. Some factors you find out that they're not so important. It's not as important as you thought. Okay. Okay. So, okay. Yeah, there are clustering techniques. This is for what do you call this? Unsupervised machine learning. Later on, okay, we won't have enough time to do the composition because sometimes, okay, it's not the y sometimes does not depend on just x1 or x2, okay, or x3. Okay. Sometimes there's a special linear combination that works best. So it could be like 1 over 2x1 plus 3x2 plus 4x3. Okay. It could be that y depends a lot on this. Okay. And then later on, it depends weakly on x2 and x3. But there's a special combination that you can use that will account for most of the data. Okay. So you can use something called PCA, principal component analysis, to find special linear combinations that the target depends most upon. Okay. Okay. Please let's take a. Okay. Okay. So let's take this example again, and I'm going to try to write something again for this example. Okay. So in this case, you have y, which is the weight, say in kilograms. Okay, and then you have x1, and you have x2. This is the thumb length. Okay, and then x2 you have the in millimeters, you have the waist length. Okay. Okay. So if you do a fit and you use all your data to do the fit, then there's a problem. The problem is you don't know whether if I give you another value, I mean, so if you okay, so let's do this. So I have this person that's 80 kg, okay, and another person that is 90, and then this is 40 and this is 50. And I have their thumb length, and this one is 2.0, this is 1.5, and the waist, this person is 500, this is 450, this is 400, this is 350. Okay, so you have something like this. So if you use all the data, okay, and you do your model, and then the question is, how do you know your model is good? Okay. You may say, okay, this is prediction. This is the original. And if everything lines on the straight line, then it's good. The truth is not everything rely on the straight line. You have something like this. Okay. Say something like this. This is actually quite good. Okay. If you have something like this for this 4 point, okay. If I bring another point and say somebody has a mass of 45 kg, okay. You make a prediction. How do you know your prediction is correct? Okay. Okay. It's hard to know whether your prediction is correct or not. Okay. So what we actually do when we do machine learning is we're going to take one of the data and we're not going to use it. Okay. And we're going to use this to do the training and this and this. Okay. We use some of them to do the training. Say 80% of the data we use to do the training. In this case, we're using 75% of the data, okay, to do the training. And then after we've done the training, we'll now check our model with this one that we did not use and see if when I put the thumb length of 2.5 and the waist of 500, do I get 90 or not? Okay. So even before somebody else gives me and say, please make a prediction of 4.5 make a prediction for me for somebody that has a length of 1.3 cm and waist of 420 cm, so millimeters. Before somebody comes to say, make a prediction for me for this, then we check ourselves. If I put a waist thumb length of 2.5 and a waist of 500, do I get 90? Okay. Remember, this line, I did not use it in training the model. I only use the first line, the third line, and the fourth line. I'll omit this one, and I train the model. Okay. So the one I used to train the model is called the training set, or some people call it training set. Usually it's like 80% of the total set. And then the one that I used to test, this one, is called the test set. Okay. And it's like 20%. Someone say, why not 75% or 90%? Okay. When we do it, we usually use something like 80%, 20%. You don't want something too small for the training, okay? And you don't want the test set to be too small either, okay? So 80-20 is like good enough, okay? Then, okay, so you have to split data into training and test set, okay? And how do we split it? Again, there's a library to split it, scikit-learn library. It will do the splitting for you. And it will do the splitting randomly. Okay. It's not like it will take the first 80% and say that's training, the last 20% and say that is test. No, it does it randomly. Okay. And this is where we have sorry, let me go back. Yeah. This is where we have the data set splitting, train, test, set. Okay. So it does this training and the test. Okay. So in this example, they just generate some data and they try to use the generated data to make prediction. I mean, to do the fit. Okay. They just generated some data. You don't have to generate. We don't have to use this. We can use some other data that is already there. There's this iris data set. Okay. In scikit-learn, so you can use that. In this case, you can generate the data. So let's follow this for now and just generate the data. And we look at the test set and the training set. In this example, they actually use 36% for training, sorry, for testing, that's 0.3. So that means training is automatically 0.7, 70%. Stratify preserve class distribution. What that means is that I'm trying to think what it means in this context. Okay. Let's do something that's in the case in which you're just doing a classification. Okay. You want to classify the example which the one with some of those worked on. You have materials and you want to classify whether they're insulators or metals. Okay. So let's say the insulators, there are 5,000 of them. The metals, there are only 2,000 of them. Okay. When you do the distribution into test and training, okay, you may want to keep the same ratio. Okay. So you don't want a case where a lot of the, so let's say you use 20% for test and 80% for training. Okay. So you don't want a case where most of your test sets come from the metal section. Okay. And most of your training come from the insulator. No. Okay. You want the test set also to have as much as possible the same ratio of insulators and metals. Okay. So if you use 20% there, then you want like 400 to be metals for the test set. Okay. And you want 20%, that's 1,000 to be insulators. Okay. In your test set, and then in your training set, you have the rest. But if you just do it randomly, there's a chance that you can have most of them like in the test set, you can have more insulators, more than 1,000, maybe like 1,200 insulators, and then 200 metals. Okay. But then it's not balanced with your training. So in the training, in this case, there are 400 metals. And so this is 1,600 metals. Okay. And this is 80%. So this is 4,000 insulators. So this is what this stratify yes does. Okay. It helps to preserve the distribution of the classes. In this case, there are only two classes, insulators and metals. Okay. So I think we can try to, yeah, this is an example in classification. Okay. So you can say 0 is for metal, 1 is for insulator, 0 for metal, 1 for insulator, 0 for metal, 1 insulator. Okay, and like that. Okay. Well, let's look, and then there's a split into test and train. And so you can just do something like that. This one is more interesting because in this case, there's age, there's income, there's score. And then probably you want to get the score as a function of age and income. So maybe like you want to see the score to decide which insurance to give somebody. Okay, so if the person has a high score, then let me see. Yeah, if the person has a high score, then maybe you want to give more insurance. You want the person to pay more for insurance. And if the person have a low score, then you want the person to pay less for insurance. Okay. So people that are above 40, they need to pay more for insurance. Okay. So if the person is 55, you probably want him to have a low score so that he needs to pay more for insurance. And if the person is younger, then his score is higher. Because if he's young, you don't think he will need your insurance. So he'll be one of those people that will just pay and not use the insurance. But if the person is older, it's very likely he'll use insurance. Okay. Because he's older. Yeah. So you can use this to say decide on a score on how much insurance the person should pay based on the age and the income. Okay. William has his hand up. Yeah, William, you can unmute yourself and ask.
Yeah, yes, sir. So you talked about the metal and this and the insulator before, and I want to ask, like, is it now in that case now? Do we need to actually go into the data and do the and try to not okay? Let's make this set of numbers conductor for the training sets, and this set of numbers insulator for the training set. Then so that we won't get more of the conductors in the training set than the insulators. And then in the end, in the training for the test sets, we won't get more of the insulators compared to the conductors. So do we need to actually go into there and do the spreading and do the classification ourselves for the training and test set?
Okay, that's a good question. Let me answer it this way. Okay, so we started with a set of data, and sorry, and what did we have in the data? Okay, we had the chemical formula. Let me try CaCO2. Maybe CaCO2. Okay, we had many compounds. So this is compound 0, compound 2, compound 3. I don't know, Fe2O3. Compound 4, Fe3O4. Okay. And then some people already did some studies. Sorry. From their studies, so this is the compound. From their studies, they were able to say that this, because the studies is actually, okay, they did some studies. Okay, in this case, don't worry whether it's experiment or whether it's calculation. The truth, okay, in this case, they did calculations and DFT calculations. And they were able to do from their studies to know that NaCl is insulator. I don't remember Fe2O3, maybe insulator. Okay. Okay, this is a bad example. So maybe Ca, okay, calcium, and potassium. This is metal. So they did the calculations and they were able to know that which ones are insulators and which ones are not insulators. Okay. So what we are trying to do is, can we, so class. What we are trying to do is, can we use some simple properties of all this, okay, to know whether it's an insulator or a metal, okay? This is what we are trying to do. The class was already there. So what we did is we got descriptors X1, X2. One of the descriptors is like the total mass of the total atomic number of the compound. So sodium is 11, chlorine is 17. So this is 28. You can do calcium is something, carbon is something, oxygen is something, you put the atomic mass. I don't know if this is correct. Calcium is 20, no, magnesium 12, 20, 40, yeah. Chlorine is 17, 40 plus 34, 74. Okay, so you have all these numbers. So we're trying to see if given some simple properties, if you can use that to predict whether it's an insulator or whether it's metallic. So this was given to us. This was also given to us. In a way, we determine this, but this, once you have the chemical formula, this is also given, this is also given. So all the data is given, okay, in a way. So what we're trying to do is to make the classification based on all the other information, X1, X2, X3, and all like that, okay. So like this set now, if you split it into training and test set, okay. In this set, there are only two metals. 1, 2, 3, 4, 5, 6, 7. Okay. But as much as possible, we'll try to make sure that if you split it into test and training set, okay, that the training will contain 80% insulators and also 80% conductors. And the test will also contain 20% insulators and 20% conductors. You don't want a case in which the test contains, say, 5% insulators or 30% insulators. So you try to make it balanced. Okay. So if you set this, where is it? So if you set this stratify equals yes, it will preserve the class distribution. So that's just it. Then I didn't mention this random state. What this random state does is, if you run this thing again with the same random state, because it chooses the test and training randomly, but if you run it again, you want to get the same result as before. So you set a random state, okay. Any integer you put here is fine. You put an integer here, okay. Each time it runs, it's going to run with this seed, and it's going to give you the same results like before. If you change the seed, then it's going to choose a different set of random numbers, a random training and random test set, different from what you had before. Because what usually happens is when you do this, you run it, you're going to get results. You run it again, you want to get the same results, okay? But if you want to get a different result, yes, you can change the random state, and then it will choose a different set of random number, a different set of test and training for you, okay? So I hope that tries to clarify some things for you, Williams. Okay. So I'm trying to see. Yeah, we can go through this, and you're going to do the splits for us. And I already mentioned about this generally, which is to do the transformation and to scale, so you can do that. Okay. And then once you're done with the modeling, we can find mean squared error. So I don't know the difference between mean squared error and root mean squared error. I think one is just y minus y, the predicted, the original squared. So I think this is MSE. And the other one is root mean square. So root mean square will be the square root of the MSE over the number of terms. Then you can also have the mean absolute error. Okay, so that would be 1 over n sum y the predicted minus y the original. Okay, so you can have that. This usually is for regression. For classification, okay, it's more involved. We can talk about accuracy, we can talk about precision, recall, F1 scores, confusion matrix, we can talk about this. Okay. I've not done a lot of clustering, so I can't really talk much about the scores that they give for clustering. Okay. But for regression and classification, okay, we've I think many of the people that are in the group, Christian, yes, Damilare, yes, Dr. Sholola, Ibrahim, yes, we've done a lot of this in the past. Okay. So I mentioned something about regression already. This that I gave to you, yes, I use A0 here and A1 here, and actually in this case there are two variables, but in a case where you have more, okay, so I use A0 here. I don't know how do I make this smaller. I forgot. Okay. So here I use A0. Okay, it works. And I use A1 here. And then there's A2 here. So you are trying to find these coefficients. Okay. So Xi are the future values. Y is the target value. Okay. Beta, not beta I are things that I'm trying to obtain. Epsilon represents the error. Okay. And then this is an example to I'm trying to see if this actually just a linear regression with which data set? Random data set. Okay. So the next time we'll meet on Friday. Then before then, I'll send you some data, and then we'll try to do a simple regression on it. Okay. So we get the regression and we get the errors. I'm trying to think if we'll have time to divide it into training and test. There's another thing that people do, and that is cross-validation. Okay. So when you have the data set, okay, you can split it like this into training, and this is the test. Okay. Or if you like the same data set, you can split it like this into, into the test. And this part is the training, and this part is also the training. Okay. Or if you like, you can split it. So you split it in different ways. This will be the test. This will be the train. This is part of the train. So split it in different ways. And then, so you vary the who is test and who is train. And then you can take an average. And we think this helps you to get a better estimate of the error than if you just use one of them. Okay. It helps you to get a better estimate of the error. So I think we'll do some of this. Okay, this is RMSE. I'm not sure this is correct. Oh yeah, I think it's correct. So there should be square root of mean square. Okay, so this is 1/n. Okay, then I don't need it. Okay, so I'll see how to get things across to us before the next meeting so that you can try some things, and then when we meet, we do some simple regression. We can maybe do some simple classification. The first hour regression, second hour classification. And then after that, I'll explain some possible projects that we can do. Let me look at people here. The people here were mainly in material science, chemistry. Yeah, so I think we can just stick with a project in that area. Because I went online, I looked at projects, even projects that are in weather prediction. But one of the things you can do is, if I know the humidity today and how much sunshine there was today, can I use this to predict whether there will be rainfall tomorrow or not? Okay. Or if I know the humidity today and I knew the humidity yesterday, also the amount of sunshine today and the amount of sunshine yesterday, can I use it to predict the amount of rain tomorrow? Okay. Or if you know it for the past 3 days, can you use it to predict it for the next day? So people can do this. Also, you can predict earthquakes. or you can try to predict earthquake. Let me put it that way. One of the things I tried to use it for one time was to use to predict Forex. So there's a way to know if the USD against whatever currency, if it increased twice the past, if it increased yesterday, I'm sorry, if it increased today, will it increase tomorrow? Okay. And you can look at a model and see that it may increase, but the chances are very small. Okay. And then you can check, if I look 5 days in the past and it increased 5 days in the past, tomorrow will it increase? And that's for the USD versus British pound. I found out that yes, if you use the 5 day and look at what happened the past 5 days, you can use it to predict tomorrow. So you look, it increased 5 days ago and increased the next day and the next day. If it increased 5 times in a row, you can use that to predict that the next one is going to increase. Okay. So if you do that, then you can know which Forex to buy. Okay. With a good amount of accuracy. Unfortunately, I didn't buy any because then the market shook a lot with the tariffs and everything. So I don't know if the model still works. Okay. Okay. So we'll meet again on Friday. And I think because of the group here, we'll just focus on something in material science, chemistry. Yeah, so something maybe for catalytic water splitting or superconductors. So we'll just focus on things around that area. Okay. Thank you very much to everybody. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, Prof.
Have a
Thank
good
you,
day.
sir.
Yeah, sure.